All right, so what we're talking about with Chapter 5 is we're going to use some of the equations and the identities and the properties that we've talked about so far, and we're going to expand those a little bit with some other equations that we can learn, and it's a way that we can modify, change, rewrite trig equations to where they're easier to deal with in various ways. One of the big ways we're going to do is we're going to actually rearrange them a little bit so that we can verify that one equation or one expression equals another one, and that's called verifying trig identities. Now, here are the fundamental trig identities that you should know by now. If you do not, you need to start memorizing these. I wouldn't worry so much about the even odd, memorizing them. The thing is, the easy way to remember those is just remember that sine is the odd function, so you have this situation. Cosine is the even function. Anything that has a sign in it is going to be odd as well. So for instance, the reciprocal of sine is cosecant, so it's an odd function as well. Tangent has sine in it, so it's an odd function, and so does cotangent. The only ones that are even are the ones that only have to do with cosine. Cosine and its reciprocal identity, secant. Now, these right here, if you commit that one to memory, I'm going to show you in class a way that you can get these two where you don't have to memorize these, because you're going to use these some, but you're not going to need to know them right off the top of your head. This one is huge. This one is the equation of the unit circle, if you remember, but it's also a Pythagorean identity for the sine value and the cosine value of a given angle. If you square both those and add them together, they're always going to equal 1. That comes directly from the unit circle. But if you know this one, we can do a little bit of algebraic manipulation and get these two. And like I said, I'll show you how to do that in class, so you don't necessarily have to memorize these two. They're good to know though, if you're somebody that can memorize things quickly. All these others we've actually used already, and you're going to want to know how to use those, and going to want to have those close at hand in your mind so that you can draw on them anytime you need to. Now, the fundamental trigonometric identities are used to establish other relationships among trig functions. To verify an identity, we show that one side of the identity can be simplified so that it is identical to the other side. Each side of the equation is manipulated independently of the other side of the equation. Start with the side containing the more complicated expression. If you substitute one or more fundamental identities on the more complicated side, you will then often be able to rewrite it in a form identical to that of the other side. Now, there is no one method or technique that can be used to verify every identity. Some identities can be verified by rewriting the more complicated side so that it contains only sines and cosines. Things will cancel out, things will simplify then, and maybe that'll work out. Now, a lot of times when you're verifying, you will don't think of it as an equation, even though it is. Deal with one side only, the more complicated side, and if you just absolutely cannot get that thing beat into shape where it matches the other side, then and only then would you work on the other side. Work on one side, the more complicated side first, and about 95% of the time you're going to be able to use some identities to get it to look like the other one. A lot of these are not very complicated, so don't try to overcomplicate them. They're actually pretty easy to get through. Alright, so let's do one here. Let's verify this identity that secant x times cotangent x equals cosecant x. So this is the more complicated side. I only have one term on the other side. These two are only multiplied together. So what I'm going to do is I'm going to rewrite these, and I'm going to rewrite them in sine and cosines only. So what is secant? Well, secant is 1 over cosine x. So this gives me that. And what is cotangent x? Well, cotangent x is cosine x over sine x. I know those from my identities on the previous slide there. And we're multiplying these together. Now once again, I'm only working with this side. So when I put an equals, I'm not going to say equals cosecant. I'm going to equal whatever this is once I simplify it. Well, what do we notice with our cosines here? Well, those cosines are going to cancel each other out. So if the cosines cancel each other out, that means we're going to be left with 1 over sine x. Well, what is 1 over sine x? 1 over sine x is just cosecant x, and check mark, we've made it equal to the other side. We have verified this identity. Now, when you're doing these on your homework or definitely on your classwork and definitely on the test, you must show all this work. You can't just say secant x cotangent x equals cosecant x. Yeah, it works out. Because they're all, for the most part, going to work out. If there are any that won't, I'll tell you. I'll tell you how many there will be. Most, if not all of them, are going to work out, and you've got to show me the work you do to get to where it's verified. If you do not, you have not done the work. You will not get the credit on homework or test work. All right, now verifying that an equation is identity is different from solving an equation. This is what we talked about just a second ago. You do not verify an identity by adding, subtracting, multiplying, or dividing each side by the same expression. You're not doing anything to both sides. If you do this, you've already made the assumption that they are equal. We are testing, proving that these two sides are equal. If you do something to both sides, you're already making the assumption that this side equals that side. So therefore, when I add the same thing or when I divide the same thing into both sides, I still have an equal thing. So you don't know that it's actually equal until you verified it. So don't do anything to both sides like you would an equation. All right, so let's do this one. Same thing. Actually, I'm going to let you guys do this one. I'll show you the work in just a second, but you've got cosecant x tangent x equals secant x. I want you to do the same thing I did just a second ago. Take each one of these expressions on the left side, rewrite them in sine and cosine only form, and see what cancels out, and see if you can work it around to where it equals secant x. Now what I want you to do is I want you to pause the video, try the problem, and then I'll show you the answer and you can check it. So I'm going to show you the answer, pause the video, work it out, and I'll show you the answer in 3, 2, 1. All right, so here's the work. You got cosecant x times tangent x. Cosecant's 1 over sine x. Tangent x is sine x over cosine x. Our sines are going to cancel out here. We're left with 1 over cosine. And 1 over cosine by identity is secant x. Therefore, we have proven that this side equals that side, so we verified the identity. All right, so here's another one. And we're going to do very similar to the same thing here. We're going to change everything on this side, which is the more complicated side, to only sines and cosines. So we've got sine x tangent x plus cosine x. And I'm going to change this one over here to only sines and cosines, which means the only thing I've really got to change is my tangent x, right? So what I want to do here is I'm going to do sine x, which is already in terms of sine and cosine only, times tangent x, which is sine x over cosine x, plus cosine x, which is only in terms of sine x and cosine x. I'm going to go ahead and put it over 1. And then when I multiply these two together, I'm going to have sine squared x over cosine x plus cosine x over 1. Now, at this point, I know I need to get this into one term. Why do I know I need to get this into one single fraction or one single term? Well, because the other side is only one term. So I want to make sure and I combine these together. Well, you can't multiply them because, well, hello, it's addition. And the only way that you can add is if they're like denominators. So we're going to have to get a cosine x on the bottom right here. So what I'm going to do is I'm going to multiply this by cosine x over cosine x. I can do that because cosine x over cosine x is just 1. I'm just multiplying this term right here by 1. So I'm not changing any values. So now the first term is still sine squared x over cosine x. And then when I multiply over here, I'm going to get cosine x times cosine x, which is cosine squared x over 1 times cosine, which is cosine x. So now I have sine squared x plus cosine squared x all over the common denominator of cosine x. Well, if you'll notice up here on top, this part is a Pythagorean identity. Sine squared plus cosine squared of any one thing is going to equal 1. So that means what I have here, sine squared plus cosine squared x equals 1 over cosine x, and 1 over cosine x is secant x, which verifies my identity. So that's another one of those where you're using another identity to substitute in for your trig stuff. So knowing that sine squared x plus cosine squared x equals 1 simplifies that expression way down. So now we know it's secant x. Alright, so this is another one of those similar to that. I want you guys to try this. Go ahead and pause the video. Give this a try, much in the same way that the last one was done. And then you can come back and check your answer. And I'll show you the answer in 3, 2, 1. Alright, so here's the solution. You've got cosine x times cotangent x plus sine x. We're going to split that cotangent up into sines and cosines only. We're going to write everything over 1. Everything else over 1. So we've got cosine x over 1 times cosine x over sine x plus sine x over 1. And here when we multiply this out, we're going to get cosine squared x over sine x plus sine x over 1. We need a common denominator, put those together. Once again, we only have one term. We need to combine them into one term. So we multiply by sine x over sine x, just for the second term here. So we're going to end up with sine squared x on top and sine x on bottom. So we get cosine squared x over sine x plus sine squared x over sine x. Add those fractions together now that we've got a common denominator. We get cosine squared x plus sine squared x over sine x. That, once again, is a Pythagorean identity. It's the Pythagorean identity we just talked about. It's just flipped around. Remember, if they're both plus, it doesn't matter what order we're adding them in. So that's just still going to be 1 over the sine x that's on the bottom, and 1 over sine x is cosecant. Therefore, we have verified the identity. All right, so let's give this one a look. I'm going to start with the more complicated side over here again. So we've got cosine x minus cosine x sine squared x, and we're going to verify that this equals cosine cubed. All right, so everything's already in sine and cosine, so there's not that part to start in, but I do notice here that I've got a common factor in both these terms of cosine x. So let's try something. Let's factor that out. We take cosine x out of cosine x, we're going to get 1. We take cosine x out of cosine x minus, or negative cosine x sine squared x, we're going to get minus sine squared x. All right, now this, once again, is a Pythagorean identity. Now I want to show you something. Let me move down here. And we know that sine squared x plus cosine squared x equals 1. So if we were to subtract sine squared x from both sides, we're going to get cosine squared x equals 1 minus sine squared x. So right there, notice we've got that same thing right here. So if that's equal to cosine squared x, then we can interchange them. And in place of this parentheses, I can put cosine squared x. And when I multiply those together, I'm going to get cosine cubed x. It verifies my identity. So it's not always going to be simply breaking it down into sines and cosines and simplifying out. You're going to have to use those other identities as well. So you've got to be aware of those and know what they are. And they even have to be rearranged a little bit sometimes, like this. All right, so here's another one. Looks really, really complicated, but it's actually not that bad. One of the things you should notice is you've got a single term on the bottom here. Remember, a single term on the bottom means that we can actually divide that single term into both parts on the top. So when we rewrite this, we literally have 1 over cosine theta plus sine theta over cosine theta. And then what's 1 over cosine? Well, that's secant theta. And sine theta over cosine theta is tangent theta. And we verified our identity. So if you've got a single term on the top, you can try to divide that into both parts on the top, split it up into 2 parts. Once again, here's a clue that I need to have 2 different terms, so that's going to work better. If this had been a single term, I probably wouldn't have wanted to do that, because that would have split it up. Then again, it may have worked out. You never know. There's just some things that you're going to have to learn through experience. You're going to have to try things and be honest. If it doesn't work out, then go back, start over, and try something else. That's the only way you're going to learn. Guys, you don't learn by doing something the first time and doing it perfect. If you do, you already knew how to do it or something like that. But the thing is, you're gonna fail a lot and find out a lot of things that are done wrong before you actually get good at something. That's called practice. Practice is only needed when you're not 100% on something, or when you're not even 50% on something. You practice it to get better. And in those getting betters, well, the only way that you can not be able to get better is if you get them all right. So why would you practice if you were perfect already? You're going to make mistakes. You're not going to get things right every time. Sometimes you just got to try it, and sometimes you just got to bang your head against the wall for a little bit. And work, and pick up tools, pick up tricks, and things like that. All right, so this one's going to be, it looks really complicated, but it's just a little more advanced version of the thing we were doing before, where we were combining fractions. We want to be able to put these, because we got a single term over here on the other side. So we're going to have to be able to put these together. And to put those together, we're going to need common denominators. Now, before you start freaking out and saying, you know, I don't know how to do this, blah, 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 just take things a little slow. Now, there are multiple ways you can go about this. I'm going to go about what is generally the easiest way to do it. But I'll go back and I'll talk about another way that you could do it when we get done. So we've got cosine x over 1 plus sine x plus 1 plus sine x over cosine x. And what we're going to do is we're going to work to get a common denominator. So we've got cosine x over 1 plus sine x plus 1 plus sine x over cosine x. What we're going to want to do is we're going to multiply this one by cosine x over cosine x. Because in this case, the simplest version of the least common denominator is going to be cosine x times 1 plus sine x. Over here, we're going to have to multiply 1 plus sine x over 1 plus sine x. Now, when we do this, we're going to end up with cosine squared x over cosine x times 1 plus sine x. Plus, when I multiply this out, I'm going to have to FOIL. So I'm going to have 1 times 1 gives me 1 plus sine x plus 2 sine x plus sine squared x. All over cosine x times 1 plus sine x. Alright, now one of the things that I notice right here is I'm going to add, I've got my common denominator, so I'm going to be able to add my numerators, and I can see here and here I've got cosine squared and sine squared. Well, if I'm adding those, what do I know? Cosine squared plus sine squared equals 1. That's interchangeable. That's going to simplify me up quite a bit. So I'm going to go ahead and move this sine squared all the way to the front. And you got sine squared x plus cosine squared x plus 1 plus 2 sine x all over cosine x times 1 plus sine x. So once again, this right here is nothing more than 1. So I can interchange that. I'm going to have 1 plus 2 sine x. So when I combine that, I'm going to have 2 plus 2 sine x over cosine x times 1 plus sine x. Now hopefully you see right here in that numerator I got a common factor of 2 that I can take out. If I factor a 2 out, I'm going to end up with 1 plus sine x over cosine x times 1 plus sine x. And what do we notice there? Those are going to cancel out. 1 plus sine x divided by 1 plus sine x is 1. So we're left with 2 over cosine x. And the 2 is out front, and 1 over cosine x is secant x. So I verified my identity. Now, there is another way that you can go about this. And what you end up doing is you end up multiplying by the conjugate of this, what's on bottom right here. And you'll end up getting the exact same thing. It all verifies out the exact same way. But what you can do then is, let me write it in here so you can kind of see it. If I do 1 minus sine x over 1 minus sine x, what you end up getting when you multiply down here is 1 minus sine squared x. And you're only multiplying it times this one right here. Over here you're going to multiply by cosine over cosine to get a cosine squared down there, so you got a common denominator. Because, well, we know 1 minus sine x squared x is. It's cosine squared from that exact same identity I used right here. So there is other ways of doing this. So don't think that this one way you've got to memorize and that's the way that's always going to work. It's not the case. You've got to know all these other things so that you can try new things and different things. Now, from that last one, we're going to carry it over into this one. And I'm going to take this side right here because it's more the most complicated. Now, it's the most complicated because I've got more than one term on the bottom. This one's really easy, and we're going to end up changing that in just a second. But let's not worry about it right now. Let's worry about this side right here. So we've got sine x over 1 plus cosine x. And what I'm going to do is I'm going to multiply top and bottom by the conjugate of this. So 1 minus cosine x over 1 minus cosine x. That's only on this side right here. So what I'm going to end up getting is sine x times 1 minus, rewrite that where it's legible. I know, and some of you guys are laughing right now. That's legible. And then when we multiply this out, that's just a difference of squares, so we're going to end up with 1 minus cosine squared x. Now, here's the thing. If you need to FOIL that out and verify that it is this. If you don't recognize that, you better FOIL it out. If you go in here and you say, okay, 1 squared is 1, cosine squared is cosine, but then you don't know whether it's a plus or minus, you've lost some things out of geometry that or algebra that you really need. Recognizing a difference of squares is one of them, or the product of a sum and a difference. That's what this is. But it gives you a difference of squares. And we learned that difference of squares factors into these two things here. Guys, that's something you've got to retain. That's an important idea. And it shortens down a lot of this work when you go through it. So anyway, now we've got 1 minus cosine squared x. Well, what is that? Well, from the Pythagorean identity, sine squared plus cosine squared equals 1. We can move the cosine squared over just as easy as we can the sine, so we would know that sine squared x is equal to 1 minus cosine squared x. Minus. So 1 minus cosine squared x is sine squared x, so I can put that in place of this. So we end up with sine x times 1 minus cosine x over sine squared x. And this sine x is going to cancel out with one of those. So we end up with 1 minus cosine x over sine x, which verifies what I've got right there. So we actually did not have to go over there and simplify that any. Thought we might have to. All right, so this one, we're going to end up using the odd-even functions. Now we know that sine is an odd function, therefore the sine of negative x is negative sine x. So that means this is going to change to a plus when we do that. So we've got tangent x plus sine x, because remember sine of negative x equals negative sine x. When we subtract a negative, it's the same thing as getting a positive, over 1 plus cosine x. Now we want to do this since I've got a tangent in there, I want to get all sines and cosines. So I'm going to do sine x over cosine x plus, I'm going to go ahead and write this sine x as a fraction. And I'm just going to let the bottom tag along for a while. I'm going to combine these on top. So I'm going to need a common denominator, so I'm going to have to multiply this one by cosine x over cosine x, so that there's a common denominator with those two. And I'm going to end up with sine x plus sine x cosine x over cosine x, and that's still over the bottom here, 1 plus cosine x. And this over here, in case you are missing it there, that's sine x plus sine x cosine x, where I multiplied or added this together, sine x plus sine x cosine x. That's all the numerator there is. Now I've got a common factor on top of sine x, so I'm going to go ahead and pull that out. That's going to leave me with 1 plus sine x, or sorry, 1 plus cosine x over cosine x, and that's all over the 1 plus cosine x that's just tagged along the bottom. Now at this point, I need to do something with the bottom. Now if I've got a fraction divided by something, remember you can always do division. Division of fractions is keep, change, flip. I'm going to keep this one on top just like it is. So sine x, 1 plus cosine x over cosine x. And then I'm going to multiply, change the operation to multiplication, and flip the bottom. Well, 1 plus cosine x right now is understood to be over 1, right? So when I flip it, I'm going to multiply by 1 over 1 plus cosine x. And what do we notice? Well, we notice that this 1 plus cosine x and that 1 plus cosine x are going to cancel out. When we see that and do that, we're left with just sine x over cosine x, which is tangent x, which verifies my identity. All right, so for this one, we're going to have a little bit of manipulation, and we could work with both of them, both sides, and it's right at the end, so I'll show you how to deal with that. But we've got 1 over 1 plus cosine theta plus 1 over 1 minus cosine squared theta equals 2 plus 2 cotangent squared theta. So let's look at simplifying the left side first. We want to get it into one fraction, and that means we're going to have to get a common denominator. And to multiply and get a common denominator, what we're going to end up doing is multiplying by not the reciprocal, but the conjugate. Yeah, I couldn't think of it there for a second. So 1 minus cosine theta over 1 minus cosine theta for the first one, the conjugate of this. Now, it just so happens it's the same thing over here as what we've got over here. And we're going to multiply this by over here by what we got on the bottom over there. Now, it just works out that way. It's not always going to be that way. And the reason we're doing this is because, back to the difference of squares thing, what happens when I multiply 1 minus cosine theta times 1 plus cosine theta? Well, when we FOIL this out, we got 1 times 1, which gives me 1. Positive cosine theta, negative cosine theta, my middle terms cancel out, and I'm left with just minus cosine squared theta. Now, if by now your spidey sense is not going off when you see that, then you got something wrong, or you really don't care about this work. But that right there helps you a lot, because 1 minus cosine squared theta from that Pythagorean identity is sine squared. That's a good thing. All right, and same thing over here. When we multiply these two, we're going to get 1 minus cosine squared theta, also known as sine squared, and on top 1 plus cosine theta. All right, so down here, both of these are going to be sine squared squared theta by Pythagorean identity. So our denominator is going to be sine squared theta. Now, when we add our tops, we're going to get 1 plus 1, which gives me 2, and negative cosine theta plus positive cosine theta, which gives me no cosine thetas left over. So I'm not transferring anything over. Now, right here, you're going to know, oh, look at there, 2 over sine squared theta. So that's going to be 2 times cosecant squared theta. There's only one problem. That doesn't match what I've got right here. But if you look back at your Pythagorean identities, what does cosecant squared theta equal? Well, cosecant squared theta equals 1 plus cotangent squared when you do some manipulation to it. Now, so that means we've got 2, and in place of this box, I'm going to put 1 plus cotangent, not cosine, squared theta. And then when I distribute the 2, I get 2 plus 2 cotangent squared theta. Now, I know that just because I recognize the fact that I'm going to cotangent stuff from cosecant stuff, and I've got that Pythagorean identity. Now, another way you could do it is, once you get to this thing right here, that you can because we actually complicated it when we went from here to there. We made more terms out of less terms. We're complicating things there. So what you could have done is you could have stopped right here, and then you just, instead of going to this part, let's go ahead and get that out of the way, just make a note, right side, and do 2 plus 2 cotangent squared theta, and then factor out the 2 and 1 plus cotangent squared theta, and then 1 plus cotangent squared theta is cosecant squared, so you get 2 cosecant squared theta. Now, you got to show all this work, but it's all just recognizing and using things you should already know, or are in the process of getting to know. So make a note if you move to the other side. So I got to this point, and I can't simplify that anymore. If I don't recognize, hey, I've got that identity that's going to make this thing look just like that, then move to the other side, because there's nothing else you can do with this as far as simplifying. So once you get there, stop, make a note that you're moving to the right side in your work. If you don't make the note, I'm not going to see this jump from there to there. There's nothing that tells me, oh, I want to do that magically. You know, you've got some work that you could show in there to make it that, but you're not showing the work if you just go from there to there and then do this. So make a note that you're moving to the right side, and then just simplify the right side down to one term. And then, now we've got both sides. This was the left side, and this is the right side, and both of them equal the same thing. You verified the identity. All right, so here are some guidelines. This is in your book, so you can look at that. It's later in the section, if I remember correctly. And I'm not going to read through this, but I do want to point out one thing right here at the bottom. Just what I said at the very beginning. Don't be afraid to start or to stop and start over again if you're not getting anywhere. You've got to know strategies, and you're only going to learn strategies by trying things. Okay, creative puzzle solvers know that strategies leading to dead ends often provide good problem-solving ideas. You're going to see things as you're going through. Try something. If you end up going through, let's say I'm working a problem and I'm going through, don't go back and erase all that. Just put a big X through it and then move over here and start again. And then start. You don't have to go back and erase it. All right, so that's all for this section. Have fun.